Hello, everyone, and welcome to today's webinar sponsored by Cemex. My name is Katie Gillum. I'm the event director for Greenbuild, and I'll be your host for today's session titled From the Ground Up, Building Resilient and Sustainable Buildings Using Low Carbon Concrete. First, some quick housekeeping items. I have a few things to cover here, so bear with me, but if you experience technical difficulties, audio, advancing slides, etc., refresh your screen with F5. If you have any other issues or if they're persistent, hit the question mark button and one of our team of experts will give you some assistance. At any time during the presentation, submit your questions into the Q&A window on the left-hand side of your screen. We'll do our best to get to as many questions at the end as possible. And new to this platform, there's a reaction widget down below, so feel free to share your reactions to the presentation today. This course is also approved for 1 GBCI and 1 AIA continuing education credit. If you attend the full session and submitted your information in the registration form, these credits will be reported for you. So please allow 4 business days for the credits to be reflected in your accounts. If you need any additional support or you're not seeing those credits, you can contact program@greenbuildexpo.com. That's program@greenbuildexpo.com, and they can support you there. In 24 hours, you'll also receive a link to watch the recording of this session. The recordings do not carry those same live CE credits, so just a note there. So I am going to introduce our panel today. So we have 2 speakers, Corey Zollinger, Director of Infrastructure Solutions, and Jim Mack, Director of Market Development for Infrastructure and Sustainability, both representing Cemex. So I will pass it over to Corey. Corey, the floor is yours.
Thank you. We're excited to be here today to share with you some work that we've been doing regarding sustainable buildings and the use of low carbon concrete. My name is Corey Zollinger, as you mentioned. I work predominantly in the western half of the U.S., and I'm joined today by Jim Mack, my colleague. So with that, we'll get started. Jim does most of his work in the eastern half of the U.S., so together we're going to work to go through this with y'all today. We thank you for taking the time to listen to us for a little bit. If you're not familiar with Cemex, we are a global company involved in the production of cement, ready-mix concrete, aggregate, as well as admixtures, and then we happen to ship cement all over the world as well. To supply the needs of our operations. Here in the United States, we operate, again, cement plants, admixtures, but most of our operations are in the southern half of the U.S., working from California all the way to Florida in certain markets. We are actively involved in this topic of sustainability and low carbon concrete. And today we're going to go through and talk to you a little bit about how you can implement those things on your projects. As a company, we are absolutely committed to achieving net zero concrete and helping our customers, specifiers do the same thing. We have kind of organized our efforts in what we call our Future in Action program. We've got that built on 6 different pillars that we are focusing our efforts on. I think it's important for y'all to know that we are going through everything in our operations that we do, from the products and solutions that we produce to our operations, and trying to figure out how to decarbonize those from the products that we buy to the products that we produce. We're actively involved in the circular economy and reusing, recycling products. One of the things that's become a lot more important recently is just the use of water. And obviously in the making of concrete and cement, we use a lot of water, and so that's become an even more important topic to us as well. So We're doing a lot on the side of trying to innovate and partner with researchers, partner with developers, specifiers, architects, that sort of thing, so that we can continue to support the growth of the green economy. So that's kind of a quick intro to who we are as a company. One of the things that we have found really important is to share our goals. And when you share your goals with people, they're able to help hold you accountable to those goals, but also gives us more motivation to achieve our goals. And we recognize the importance of achieving net zero concrete. We've committed to do that by 2050. And so these are very aggressive goals. We know that we need a partnership with everyone that's involved in the construction community, all the way from the owners, specifiers, all the way down to those who are installing and placing our concrete. We've set some goals for 2030 that help make sure that we're on the right track of getting there. We've focused on both the scope 1, 2, and 3 goals to make sure that those are aligned. We've also gone out to make sure that these goals are validated through the science-based target initiatives, and working through a lot of programs to implement these types of goals. But one thing I will say is they're aggressive, and it's really important that we do find partnerships to help implement the solutions that are needed to achieve these goals. One thing that's become clear to us is that a lot of times specifications, designers are writing things into specifications that actually make it harder for us to achieve these goals. And so for us, it's really important that we communicate with each other so that we can better understand how we can collaborate and work together to achieve our goals as well as yours. So today we've got quite a good agenda. We're gonna go through kind of how to specify low carbon concrete, how we account for the carbon dioxide in concrete, talk a little bit about how we're designing those mixed designs and the factors that are coming to play in the future that will affect our ability to do so. And then we'll finish off with a little bit about the built environment and talking about our low carbon concrete that we call Virtua. So first off, why is this important to us as a company? And really kind of get into that. Number one, we're seeing just a lot of different influences that are coming to the table. Number one, we work with our federal partners a lot, and you're just seeing a lot more buy clean policies that are coming into play, whether they're at the federal level or at your state or local levels. We're definitely seeing those. And, we're wanting to be responsive to those policies and support those policies where we possibly can. We're also continuing to see more involvement, more requests to help support green building certifications like LEED and BREEAM and Envision and those sort of things. As well, just more awareness is being built right now. We're getting a lot more requests from developers, from contractors that have established their own goals and implementing them on projects and asking for us to help collaborate with them to help achieve those goals. So we're definitely seeing just this need for sustainability and low carbon solutions being requested in all different aspects of the work we're involved in. Just to kind of give you a little bit of a picture of the type of policies that we're seeing, we try to kind of map out the federal government or the government implemented carbon policies that we're seeing. And it's really hard to keep track of all of these, obviously, but as we mentioned, we're seeing them at the federal level, but we're seeing them really come into play at both the state level as well as local cities and counties that have implemented different policies. And most of those times when they're in our markets, we're trying to collaborate with these agencies so they understand, what's achievable we can do together to help hopefully reduce our impact on the environment. The other thing that we're seeing is a lot more requests from private developers that are truly on a mission to reduce their carbon footprint. And because they're buying a lot of concrete, they're putting a lot of concrete, obviously, in their foundations, their walls, and that sort of thing. they're coming to us and asking us how we can help them. As an example, we work with Prologis quite a bit. They're one of the largest landowners in the U.S., building industrial warehouses, and they have a pretty big impact. And so they've created their own goals, similar to us in terms of what they're trying to achieve in their operations and in their construction. And so the more requests we're getting like this, as we mentioned, it's really important that we're responsive to them, helping them achieve their own goals. So with all that coming to play, it's becoming really important that we are transparent in the way we're going about this and able to share with others the progress that we're making. And so, as you're aware, we work with a lot of different audiences, some that are very familiar with environmental product declarations and some audiences that aren't. And so with a large audience today, we thought we would just begin by discussing environmental product declarations and how important they're becoming in our business today. Historically, when concrete was procured, we would get a request in a specification that lists the engineering properties that a concrete mix needs to meet. And then we would ask, to provide a price that the concrete would be. But now what we're seeing is a lot more requests for environmental product declarations to be provided along with the price of our concrete. And so it's been important to us to be aware of that and make sure that our mix designs have environmental product declarations that go with them. If you're not familiar with an environmental product declaration, a lot of people has a nutrition facts label for the product that you're buying, and any product that you use can have an environmental product declaration associated with it. Since we're talking about concrete, cement and concrete today, this is for a cubic meter of concrete produced at one of our plants out in California, and it's for a 5,000 PSI concrete. And most of the time we're talking about carbon dioxide, global warming, but there are impacts that are also noted on these environmental product declarations from ozone depletion, acidification potential that we also report. One of the key elements here is to recognize that for every mix design, you get a unique environmental product declaration. And as you change, different requirements for your mix designs, you'll also get a different environmental product declaration. And so what's happening nowadays is learning that when we change an engineering property that we're looking for, we understand how that's going to impact the environmental product declaration or the global warming potential. And so is work with the specifiers in the local market so that they can better understand what is truly achievable from an engineering properties perspective and a global warming potential perspective. The reason we're able to do that is our commitment to producing environmental product declarations for the products that we produce. We have taken the time and energy and money to get environmental product declarations done for every cement plant that we have here in the United States. We've got 8 of those spread throughout the markets we operate in. And then we've also gone and done this at nearly all of our concrete plants. What is really unique about what we have done is created the ability to generate an environmental product declaration on demand for any mix design that we produced at any of these plants, really within seconds. And so that gives us the ability to communicate with the specifiers or communicate with owners to help them understand what is achievable when we change, the different specifications and whatnot. Now that we, understand that we can measure the global warming potential and the other impacts of our different concrete mixes, the question is, how can we actually reduce the carbon footprint of concrete, and what steps that we need to take so that can be done? And so the first thing we do is try to understand, okay, well, what causes it, right? What is the main contributor to that? If you look at a cubic yard of concrete, we're putting by volume, we're putting in a lot of coarse aggregate, fine aggregate, water, and cement, along with maybe air content, admixtures, things of that nature. However, when you look at the embodied carbon within a cubic yard of concrete, what you find is that the cement portion of that volume really dominates the impacts, the environmental impact, global warming potential. And so, you know, we typically say that that's about 85 to 90% of the impact. Now, obviously, it's important to, you know, use recycled aggregate where we can and whatnot, and look at transportation and those sorts of things. But the work that we can do to lower the impact of the cement is really important. And so today, through the rest of our presentation, we're going to discuss what we can do on the cement side of the house so that we can reduce those impacts. So we talk about the different levers that we can pull when we're designing a mix or things that we're operating at our cement plant that we can do to reduce that impact. One of the first key elements that's been implemented through a good portion of the United States so far, but not completely, is the switch from an ordinary Portland cement to a Portland limestone cement. We often call that a type 1L cement. And I'll get a little bit more into that in our following slides. The next move beyond limestone cement is moving to what we call a blended cement. And that follows the same specification under the limestone cement. But nonetheless, it gets a little more creative and a little bit more unique, and we'll get more into that. Some of the things that we're doing at our cement plant is looking at the fueling sources, the energy sources that we're using, obviously, to heat up our kilns. We've got to heat up the kilns to an incredibly hot temperature. So how do we do that? You know, historically, we have used petroleum coke or coal or things of that nature. But what we're doing now is looking at alternative fuels. You know, we do a lot of pretty cool things at these plants that help us do that. We may be injecting tires as an example. And you might think of tires as being a bad thing, but it actually reduces the carbon footprint of cement that's produced. And we're able to take what is a waste product and put that, you know, and take care of it right instead of landfilling those. We burn a lot of biomass and other things. We're doing a lot of research with hydrogen injection because that helps us increase the amount of alternative fuels that go into our plants. We've done a lot of work with renewable energy, putting in things like windmills, solar panels, as well as looking at alternative, very unique forms of energy, like using the sun, for instance, to heat them up with some different cool technologies. On the concrete side of the house, we're learning and developing a lot on the supplementary cementitious materials. You've historically been familiar with the use of fly ash, but that is an evolving topic right now, and I'll get more into that as we're using other products like slag and pozzolans and things. There's definitely opportunity for us to just optimize our mix designs, and that could be done through the type of aggregate that we use, or it could be admixtures and things of that nature. And then finally, we're doing a lot of work with carbon capture, both at our cement plants, as well as putting some of that carbon into our concrete. So there's a lot of different things that we can be doing, and a lot of our ability to implement these on projects depends upon how the specifications for the projects are written by the specifiers. So let's get into a little bit more details, and we're going to hit some of these at a pretty high level today. If you'd like more details on some of these topics, we can definitely go into them at a later date. As an example, that we're gonna spend a little bit of time talking about limestone cement here. We have a whole entire presentation just dedicated to implementing limestone cement. So limestone cement is a specification found under ASTM C595. Historically, cement has been specified through ASTM C150. So it does require a change in your specification to allow for the ASTM C595 cements. And what it does is it moves the allowance of limestone content to move from 0 to 5% to up to 15% interground into your cement. It's the last process of making the cement powder. Most of the producers that have moved into a limestone cement here in the U.S. are between 10 and 12%. Typically, you get a carbon reduction of about 7 and 9% when you do this. The goal, the design of this is that we're designing it to form equivalent to your ordinary Portland cements that you've been using for the last 50 years or whatever, right? It's typically ground finer. What we have seen are some issues on the water demand side, but not a higher water demand, but some do. We have seen some issues with bleed water, for instance, but ideally you're achieving very similar strengths, similar set times, and things of that nature. You can find the color is a slightly lighter color, depending on the color of the limestone that's used. But what's really important to know is that every DOT has accepted Portland limestone cement as of February of this year. And so it's definitely a great solution to implement on your project. It's becoming more and more available. There are still some markets where the cement plants haven't transitioned over to producing this product yet. And that's usually due to the functionality of the cement plant and the ability to feed more limestone into their kilns and things of that nature. But most of the producers are working towards being able to produce limestone cement within the next short time frame. What's also happening right now is a true evolution of the use of supplementary cementitious materials, as I talked about. Fly ash has been around for a long time. There's a lot of familiarity with it. We're seeing more and more availability of slag being either brought into the U.S. or produced domestically. Silica fume has been around for quite a long time, but the other thing that's starting to come more prevalent, especially in the western half of the United States, is the use of natural pozzolans. And as those get developed, you're going to start to see them become more common around the U.S. What's really important here to understand is SCMs do two key things for us. Number one, they increase the durability of our concrete to fight against things like alkali silica reactivity, freeze-thaw durability, things of that nature. But it also reduces the carbon footprint of our concrete by a significant manner. So every percent or so that you put into your concrete mix, typically it lowers your carbon footprint by about 1%. Very impactful. As we mentioned, there have been in the past few years that you've probably become used to hearing about. And you might be thinking, well, geez, that's great that you want to use more fly ash, but how are we going to do that with coal plants being shut down and that sort of thing? And the answer is the development of other SCM type, reclaimed coal ash. When power was being produced, coal was being consumed, maybe in the colder months, but maybe concrete wasn't being produced, fly ash was being stored in these humongous ponds. And those ponds are now being evaluated for what they call a beneficiation of the fly ash, or reclaiming that ash and making it available to be used in making concrete or making cement. There's also quite a bit of work going on in natural pozzolans and developing those so that they can be used in cement or concrete. There's a lot of really different cool technologies like geopolymers and that sort of thing that are also coming into play. So what you're going to start to see in the cement industry is a true evolution of cement production. That's already begun. It began probably around mid-20s, accelerating over the next few years. The limestone cement, as I mentioned, is happening, but the blended cements are coming into play. We call that a Portland pozzolan cement, a slag cement, or a ternary blend. And what happens, the reason we're doing this is we're reducing what they call the clinker factor. And so what that means is when we produce clinker, it's a rock that when the cement and the clay go through the kiln, it comes out in a rock form. And then we put it in and we grind in just by adding in other things like natural pozzolans, things of that nature. We're reducing that clinker factor of what we're going to ship out. And so by doing so, we're also reducing the carbon footprint of that ton of cement. So the question might be, okay, if you're moving to ternary blends, how are you going to do that, right? Where are you going to get the raw materials to be able to make that possible? And the answer is, I talked a little bit about the coal ash. This gives you a perspective in terms of where the fly ash is available, where it's being produced. If you look at this map, it's pretty easy to see the eastern half of the U.S. is doing in terms of coal ash availability. The western half of the U.S. is not, and so that's definitely a challenge. But so when we talk about our ternary blended cements, in the eastern half of the U.S., it would be a limestone plus maybe a coal ash, due to the location of these. This gives you kind of another, those ponds are located and the availability of them. So there's plenty of that available as it becomes more potential. Now, the next question is, okay, what about natural pozzolans? The natural pozzolans tend to be located in the western half of the U.S. So your ternary blends of cements in the future won't likely include the limestone, but will most likely include like a natural pozzolan instead. So you're going to see that the cement being produced will be different depending on kind of where you're located and the type of cement that's available. Another little picture is kaolinite. It's another, you might have heard it called calcine clay, that sort of thing. Again, there's some more availability of it, and there's a lot of work that's being done. What I would say is the natural pozzolans are probably ahead of schedule in terms of implementing those. But nonetheless, another player that will come into the picture. And then finally, just wanted to highlight the importance of mixed design optimization. Without any of these other kind of technologies that I talked about, often we can optimize our mixed designs through choosing maybe a different combination of aggregates. And surprisingly, what that does is it reduces the amount of cement that we might need in a mix. It has a lot of good durability benefits because it reduces the shrinkage of the concrete, increases density. There's a lot of great benefits to it. There's also a lot of admixtures that have been developed recently that also help us to achieve these and use less cement in the mixes. What we wanted to do was give you a little bit of perspective in terms of the impact of using these different levers in your concrete mixes and the potential reduction in global warming potential or carbon dioxide that you would see by implementing just these simple levers into your specification. So you can see whether it's limestone cements, blended cements, you're typically 7 to 8 up to even 10% reduction in your global warming potential by including some of these technologies. So while it's not 100% that we'd like to see, it's definitely an improvement. With that, I'm going to turn it over to my colleague, Jim Mack, and let him.
Thank you, Corey. Appreciate it. It was, thank you for that up. Everything Corey's talked about up to this point is kind of how to make low CO2 concrete and some of the things we can do. And a lot of that is already implementable. It's stuff that's been used for the last 15, 20, 30 years. It's just bringing it out into the forefront and specifically trying to implement these on projects. So what we thought we would do kind of now is talk a little bit about how to specify some of these things. And the number one thing we can do is actually change how we specify materials. Right now, almost everything is a prescriptive specification. And what that does is it tells you how you're going to do things. So it's going to say like, use a minimum of 550 pounds of cement in your mix, or no more than 15% fly ash allowed. And so you're kind of tying our hands on what we can do. If we open up our specifications, we can actually improve our mixes, lower the cost, lower the CO2, and actually get a better product. And so what this slide is showing us is some of the restrictions we often see in specifications that actually impact our ability to do things. And the biggest one is like restriction on some supplementary cementitious materials, what type we can use, or how much we could use. And so as we go through these, we can actually get a reduction. What we would like to see are what are called performance-based specifications. So instead of telling me which aggregates to use or how much binder to use or how much water, what we want you to do is tell us what strength do you want? What shrinkage do you want in your concrete? What modulus do you want in your concrete? How durable do you want it to be? How permeable? And kind of tell us what your performance expectations are. And when it comes to that, then we can design the mixes to meet your needs. And so that's kind of the key thing. And so when it comes to specifying concrete, that's what we're asking for. It's defining the goal and not so much how to do it. As a company, as architects, engineers, and people who design things, we know what we want, but we may or may not know the materials in the area. As a company like Cemex, our job is to know what materials in our area, and our guys work with them on every day, and they know what materials go well together. They know what strength we can do, and they know how to manipulate those materials to give you the designs or the strengths or the characteristics, the performance parameters that you're looking for. The other thing we want us to do is actually let's make a GWP part of the specifications. And so to do that, the first thing we want to do is kind of look in your area, look at EPDs, find out what's possible in your areas. And so we're going to talk about benchmarks in a couple of slides, but one of the things we see consistently is a lot of the benchmarks that are made now are multiple state benchmarks. But what happens is as we move through the products and how far things are shipped or what materials are available, we can have places we can meet those very easily, and other places we can't meet them hardly at all. It's just based on the area. So that regionality becomes a big important factor. Another thing we would like to see is a project budget for the CO2, for the total project. Right now, there's a lot of specifications that are being put out there that are kind of go, no-go specifications. They say if you're above 220, you know, don't even bother bidding, but if you're below 220, you can bid. Well, what we would rather see is a total project budget. And as a material producer, let us produce what it is and let us come up with a budget that'll fit that. And I'll show you an example of that in a second. Again, I talked about the no-go specifications. Those limit competition, and it limits my ability to bid on maybe just a specific mix. But if I have the whole project, I can actually develop a more comprehensive solution for you. The other thing we'd like to see are incentives. We also like to see parts of the project where if you're worried about pouring, we have test pours and things like that, just to show that we can do it. And we find out when we pay for those and do things like that, what happens is you take the risk away from the contractor, you take the risk away from the material supplier, and you kind of equalize it so everybody's out there and they kind of look at it and they figure out this is how we have to make those projects go on. So those are some of the things we think will really help us in the project specifications. But here's what we mean by project budget. Corey talked about for pretty much every project, we're going to have different applications we're going to be looking for with different strengths requirements. We're going to have different volumes. And so what we would like to see is for like the concrete, the foundations, the walls, the columns, is we look at a regional benchmark and kind of set some targets, kind of here's what is pretty, can be achieved in this area. And then we set a target for it, something like 80% reduction, and then multiply the volume by the application target, and you get a total estimated project GWP limit. Now, here's where it comes important. Instead of requiring us to meet each one of these limits, the 321, the 338, the 321, allow us just to estimate or beat the project GWP limits. Because what that does is that gives me, as a supplier, to places where, hey, if I know I can really optimize a mix for like my foundation, I can get a big reduction there. And maybe for something like a wall that has to be put up very quickly, I only have 2 or 3 days before I have to open it, or columns that I'm going to load very quickly. At that point, the engineering needs outweigh the GWP factor, so I have to make sure it stands there. So I may not be able to meet it, but I can typically meet the entire project budget on this, and so I can come up with a savings. And that allows multiple producers to participate, and it allows them to get into the game, and that helps drive the costs down. One of the things that's coming up, and kind of a preview, is there's the ACI committee, it's 323, is developing a code requirement for low carbon concrete. And that's under development. It's actually out for public review. And it kind of builds off of this. And so what it is it kind of starts looking at, here's how to define CO2 or how to use low carbon concrete on projects. And what they have done is they set limits based on the project type and the project size. So if I have a large project, what the code is going to be requiring says, look at your regional benchmarks. Then the more regional, the more localized, the better. If you don't have anything, you can use the NRMCA regional benchmarks, but then the target is 85% of that. Provide EPDs, and that's kind of where you're going to be there. They do talk about the project budget in there also. For medium projects and smaller projects, a little bit less requirement. Medium projects, provide EPDs, and then on small projects, at this point, no requirement. And this is intended to be a first cut, but it is something we think we'll be developing over time. Now, a couple times I've talked about the benchmarks. So here are some examples of where what the regional benchmarks are. Typically, they're based on strength of the concrete. And as Corey mentioned, we're predominantly a South U.S. company. And so the areas we work in are the Pacific, the South Central, and the Mid-South or the East region. And so you can see these are what NRMCA currently defines as the regions. So we can see is like over here on the West, for a 3,000 PSI concrete, typical factor that we could get to our typical GWP is 248, but our target then would be 85% of that would be 211. Typically what you can see as you look across this too is, there's some places it's much easier. Typically in the South, especially like Florida, it's much easier to get low strength or low carbon concrete. They just have good aggregates. They get good strengths, with a minimal amount of cements. Out in California, it's going to be a little bit more difficult. It's just the aggregates aren't quite as good, and there's some bonding issues, and so it just takes a little bit more to get there. So we need to understand that regionality. But we also have to understand that it's not just on a statewide basis. So what we've done here, just to kind of show you how it can vary, is we've took the ACI, their basic standard mix that they say this is the average of all mixes, and we've calculated here's the GWP that goes with them, here's the benchmark values, and then we actually created EPDs for each one of those mixes in 4 of our plants in Texas. And what we can see in Houston on the east side or on the west side of Houston, we can pretty much make it. It's fairly easy. We can, it's close. On the other side of Houston, where we have imported cements and imported aggregates, a little bit more tough. Out in San Antonio, it's a much easier market. There's a lot of cement plants out there, not a lot of transportation. It's easy. But down in the valley, it's going to be difficult. And so this is why that regionality becomes an important aspect, because we need to understand what's going on there. And I know this is a lot of information, but this is where engaging with your material suppliers early on in the discussions of what can be done and what cannot be done can help you set that up. So give Corey and I a call, talk to your local ready mix suppliers, your local cement suppliers, and they all can help you figure out, hey, this is what can be done in this area. Now, we've been talking about the materials and all the things that we can do with those, but one of the things we like to kind of drive home is that cement and concrete are not really the end products. They are, they're used to make the homes, buildings, hospitals, bridges, all that stuff that make our society better. And it's not that so much that we want low carbon cement and concrete. We do, that's helpful, but what we really want are low carbon buildings. We want low carbon hospitals, low carbon pavements. And when we look at materials, everybody's focusing very much on those embodied emissions, those upfront emissions, on buildings and infrastructure. But what we really find out is in a lot of times it's this use and operations where most of the carbon actually happens. That's where most of it occurs. And this is where concrete can actually provide some really good benefits. And this is kind of one of our strong suits because of our thermal capacity or our thermal mass. We're low energy, stiffness, so we get better fuel efficiency in our payments. So because of concrete's inherent properties, that's one of the places where we can actually provide some benefits. And that's one of our strong suits. We can lower those use phase type operations. And here's an example of that. This is from the Massachusetts Institute of Technology, their concrete sustainability hub. And so they went out and they kind of looked at different types of building constructions throughout different locations, building types, single family, multifamily, commercial, different types of construction materials, and compared the global warming potential over 60 years. And they looked at this, and what we typically see is concrete's almost always going to be higher on initial and that embodied phase in their embodied CO2 with the materials. But what we see is over their lifetimes, they have a much lower embodied emissions. And that's because, again, of those inherent properties. It's airtight, so we get better, things with the air conditioning. We are on pavements, more fuel efficient, things like this. So if we design our buildings correctly, we can take advantage of this. There's another study that came from Europe, and it showed that while concrete buildings can have the highest CO2 and embodied, they can also be the lowest, and they have the broadest range. So we need to move everything down into that best of class things. And so when we do that, we can actually take advantage of this. So what are some of the things we can do? I've mentioned concrete's thermal mass and low air filtration rates. And what we do with these is we actually change how the building operates during the time. This is some information from a project that was done in Kansas City. It wasn't done by Cemex, but it was done with the help of the industry. And what they were able to do is change how they designed the building so that we were able to increase the lag time between the peak heating and cooling times so that we actually decreased how much we needed. And so not only do we have to use our less electricity and less power to heat and cool our buildings, we can use smaller equipment to do it also. And so what happens is we get a much more efficient building. So we just have to take that into account. Another one of my favorites, is concrete's albedo. It's typically it's a pavement type thing, but all buildings or most buildings have parking lots, or they have roofs, or they have places with it. And what concrete does is that albedo reflects the light. Global warming is a function of two things. It's from radiative forcing, which is how much CO2 is in the air, and so the CO2 captures the heat, the sunlight reflecting back out into the atmosphere, and it holds the heat in, so we're warming. But another way to impact global warming is actually to increase how much light we reflect out. And what we see is that concrete's albedo is typically higher than the Earth's average. Earth's average is about 3. So every time we're putting down some pavement or something like that, at minimum, we want to match what the Earth's kind of average albedo is out there. And that will help offset CO2. Again, studies done from MIT show that reduces urban temperatures, kind of depending on where you're at. But on average, every square meter of concrete pavement offsets about half half a kilogram of CO2 over the lifetime of the pavement system. So then it's a big number when you run through it. Now, a lot of stuff coming at you. Corey, I threw a bunch of things at you. I threw a bunch of things at you. And we know it's hard to get to or hard to remember what we can do. And so to help do this, Cemex has come up with a product we call Virtua. And what Virtua does is it basically takes all the things we've just talked about and kind of puts it into a low carbon concrete. So this is the low carbon concrete for Cemex. I should say it started out as a low carbon concrete, but the idea has actually expanded a little bit. And so the idea with Virtua was, instead of saying, hey, I want you to put 15% fly ash in there, or I want you to use fly ash, or I want you to use SCMs, I want you to optimize your aggregates. What you do is you kind of say, I want a Virtua concrete and I want a CO2 reduction, and we'll get it there based on what we have in the local area. Like I said, it started off with low carbon concrete, but as we've been working through this, we found out there's other things that actually matter just besides the low carbon concrete. That's important and we need to do it, but we find out we can actually improve the entire system by looking at other things like energy efficiency. What are some things we can do to improve the thermal efficiency? And so we have products that can do that. Water conservation. How can we conserve water, not only at our plant, but as we make the materials? A lot more recycled materials. How do we do this? And my favorite is design optimization. This is something that I work a lot on. Corey works a lot on. We're pavement engineers by trade, but we do a lot of mixed designs. And so that gets into how thick does my pavement need to be, or what materials do I need to be used, and helping you create a more efficient design that goes with that. Now, I talked about how it started off, Virtua started off as low carbon concrete, and what we have are 3 levels of it. And so, right now we're, as a company, really working to get all our concrete into what we call the Virtua Classic mode or category. And what that is that's a 30 to 50% CO2 reduction based on an industry standard normal Portland cement-based concrete. And so I know there's a lot of concern about, hey, well, we're using SCMs and we're using all the, different fly ashes and other pozzolans. Does it hurt the concrete? And the answer is no, it doesn't, because, we've been using those products for a long time already just in our normal concretes, but now we're actually focusing on how to use them better to get these CO2 reductions. Our next step is we want to get to what we call our Virtua Plus, which is going to be a 50 to 70% reduction. And ultimately, we want to get to it so all our concrete is Virtua Ultra, which is greater than a 70% reduction. And again, the reason we came up with this brand is because there's a lot of things that can be done. But if we say we want a Virtua concrete, it tells us what you're looking for. If you tell us you want 60% reduction, it tells us our target we want to go for, and we can start looking at our materials and go for there. Now, having said that, one other point is to help prove that, Corey also talked about our instant EPDs, and one of the reasons we have these instant EPDs is so we can provide this type of information to you and say, okay, on your project, this is what you were looking for, this is what it is, and so we have certificates and other types of information we can give you to kind of verify that what the concrete you're getting is this low CO2 concrete. Now, the question always comes is, well, hey, these materials, are they tested? Are they true? Can we rely on them? And the answer is yes. This is still concrete. I mean, as Corey mentioned, a lot of those SCMs, they actually make concrete better. So what happens when concrete starts to hydrate, it creates a byproduct called calcium hydroxide. That calcium hydroxide reacts with these SCMs to actually create a denser concrete. So you get stronger concrete, you get more dense concrete, you get concrete that's going to have less permeability associated with it. So anywhere you're using regular concrete, you can use these low carbon types of concretes. We have put them into residential, we put them in industrial, commercial, infrastructure. All these are places they can be done. Now, I know we covered a lot of things with you. Just kind of want to let you know that we have other training we're looking at. These are the 2 we have approved so far, but we do training all the time, and we can talk to you about any type of low carbon concrete, get very project specific, and we will be happy to help with you. And then on behalf of Corey and I, thank you very much. We appreciate the opportunity to talk to you and take any questions.
Yeah, so you guys had a lot of questions come in, so I'm going to do my best to get to as many of them as possible. We will stop at the top of the hour here. So this is a quick one. How does the cost of sustainable concrete compare to traditional concrete, and how is this justified in terms of sustainability benefits?
I'll take the first stab, Corey, you can go from. Typically, low carbon concrete's approximately about the same cost as conventional concrete. It's not going to be a huge difference. There are a few times it might be a little bit as we're switching plants and doing things like that. But for the most part, low carbon concrete is going to be the similar price as conventional concrete, not a big difference between them all. And a lot of it is because we're using some of these waste products associated with it.
Just to add to that, just quickly, limestone cement, I've seen the question about that in the chat there. It's typically about the same cost as your ordinary Portland cements. While the ternary blends have not come out in a tremendous way, I'd expect those to likely be a similar cost. It's just going to depend on how that plays out and what pozzolans or coal ashes and things get utilized and what those costs are going to be. But I would expect similar costs. Where you see an increase in the creative, right, beyond kind of what we've talked about here so far today, where maybe you want to use a glass pozzolan, but it's in New York and you want to ship it to Texas. Obviously, that's an increase in cost. So, but by and large, most of what we shared today, if not all of it, is equivalent cost to what you've been paying.
Excellent. Thank you both. Does a lower carbon cement affect durability and hurricane cat ratings?
The quick answer is no. You're going to get the same material properties out of the low carbon concrete as you would a conventional concrete. So those types of things are going to be the same. You're going to get those same materials. The one thing you may get a little bit different is early strength development. So what used to maybe be able to get strength development in 3 days, now may take 4 days or 5 days. But what we see with these low carbon concrete strengths is they're slower strength gaining, but their ultimate strengths are higher. And so you'll actually have a stronger concrete at 56 days and at 90 days than you probably would with conventional concretes.
Excellent, thank you. What do you do to manage the harmful gas released from tire burning?
Jim, you might be able to answer that one better than me. I'm not an expert in cement production, so okay. It's tough for me to answer. What I do know is it's a very negligible impact. I don't know, Jim, if you've got anything to add to that.
Yeah, in a nutshell, because we're burning these things at 1,600 degrees centigrade, it's so hot that it's a very clean incineration. In fact, the FHWA did a life cycle assessment comparing burning of tires in a cement kiln versus using it as an aggregate in asphalt pavements, as a rubberized asphalt. And the basic conclusion was, as long as you weren't shipping the tires more than 1,000 miles, it was always more beneficial to burn them in a kiln than to put them into an asphalt. There's less emissions associated with that. And it's just because it's such a hot environment, all those things get evaporated.
Yeah, I mean, I can't believe it makes sense that there are studies on this, but it's fascinating to learn about. So thank you for that. There's mention of short-term transition to type 1L 0 to 2 years per the slides. However, this person has learned from ready mix plants are not ready for that transition for at least 5 to 10 years in the Southern California market. So is there any sort of context there for you all that you want to add?
Yeah,
add some context to?
That is a really good question. The answer of 5 to 10 years is not correct. I would anticipate within about 2 years, you'll probably see the large majority of the United States moved over completely to limestone cements or a ternary cement. Right now in Southern California, that is correct. We are producing some limestone cement in that market, but it's not our predominant. And the reason is, again, it goes back to we're feeding more limestone into that kiln. And so we just need more feeders. The grinding capacity, it requires us a longer grind time. And so until we get that work done, it's literal construction at the plant, right? So until that work gets done, we'll be limited on the amount of cement that we're producing that is limestone cement. It's not that the concrete plants aren't ready for it. It's just that the work to be able to facilitate that at that particular cement plant has not been done. But you will see it happening. It's continuing to happen daily, and that's truly the only thing that's stopping it is just getting construction work done at our plants.
Yeah, and just as one point of reference, in February, about 58% of the cement that was shipped here in the U.S. was a Portland limestone cements. So the real catch, as Corey said, is, there's only so many people who can do this type of construction at cement plants, and they're busy. And so we're, trying to get them all worked over.
Excellent. So this one is a statement and then a question. So when determining the project GWP budget, it's hard to understand the total application volumes during design versus what is actually installed / brought to the site. How can you base reductions for project totals if volume numbers might differ?
I could take that one too, Corey, if you want. So kind of the way we would like to see it happen is we have maybe 3 types of budgets put together. So as you're designing the building, you come up with a as designed project budget. So I'm assuming here's how much concrete I'm going to use, here's how much I'm going to use this. And so you build that into your design. Then you can take that as to your bidding process, and you have at the bidding process, hey, here's how much, I bid it so I can compare producer A versus producer B. They kind of come in there and they give you, here's my project budget. You can pick the preferred supplier based on the budget and the price and all that stuff. The third time is at the end of the project, you kind of square all that stuff up. Say, how much did I have more concrete? Did I have less concrete? What was the actual mix I used? Did I have a different EPD than what was originally proposed? And you kind of put that all together and kind of look at it at the end and say, did I exceed that project budget?
Awesome. So we have time for one more. There's a question about how long does it take to implement type 1P, 1S IT blends at the concrete plant? Is it intensive in terms of capital, and how long does it take relative to implementation of type 1L, assuming you have your blended cement sourcing figured out?
Yeah, that is a phenomenal question. And the reason is we're doing a lot of work in the back end, a lot of iterations where we make us that 1P or 1T cement, we put it through a testing program, and then we have to remake it again to improve upon, the test measurements that we've got. So it's just the true product and a process that we have to go through to make sure that it is ready for prime time. And, every time we kind of shut down our cement plant to make a research blend, so to speak, that just takes a lot of time and energy from us. So, and then concrete testing takes a while. Sometimes you got to wait 28 days for a test result or whatever, right? So that's really the challenge is how do we implement and evaluate different technologies? We can do it at the lab, but we've also got to maybe do it at the concrete site, and then also produce concrete and put it down and see how that affects your place and finish property. So what we're learning is product development in this day and age is very challenging. Just from you look at the logistics side of things to the, where we're going to get that raw material. And then, we happen at a cement plant, you make about 1 million tons of cement a year. So you've got to have all that raw material ready to go and also reactive and also produce the quality of concrete that we're looking for. So it's definitely a lot of work is going into that by every cement supplier that exists right now.
But I think the one thing is that's a lot of the material testing. I think the capital things, the changes at the ready-mix plant, all these are intended to be done with the same type of equipment we're already using. So you're not going to need different trucks. You're not going to need different mixers. You're not going to need any type of that. They'll all be done to move to that point. The materials themselves need to be a little bit tested, as Corey went through, and that's kind of the slow process. But changing out a ready-mix plant, no, it's still the same bins, the same aggregates, stuff like that. You need to empty them, and there's a few things logistics-wise, but none of the. I don't need a brand new plant.
Awesome. Well, thank you very much. Thank you to Corey and Jim for the presentation today. And thank you all for some excellent questions. We had, I think about 50 questions that we didn't even get to. So we'll send those along to the presenters and they'll reach out as necessary. So this session was recorded and you'll receive notification in 24 hours when the on-demand session is available for viewing. Before you log off, please take a moment to complete the feedback form so we can continue to improve the webinar experience. And on behalf of Cemex and Greenbelt, have a wonderful day. Thank you, guys.
Thank you all. Appreciate you coming.
Thank you. Thank you.